So nothing's really changed.
When will your kids get out of school? Are they getting out earlier than originally planned?
Yeah, they're getting out a week early, and then they have
Yeah.
a week to go pick up their stuff. So I
Yeah.
have a 7th grade, 6th grade, and 3rd grade.
All right. I
Yeah.
have 6th grade and 3rd grade.
Okay. Yeah, and it's funny, the 6th grade, they haven't had much schoolwork. Um,
Yes.
but the 3rd grader, yeah, he's full in it.
Yeah. Yeah.
And the teacher's been really on the ball, so that's been nice.
That's great. Yeah, our teachers have done a great job, but my 3rd grader definitely has more work than my
Yeah,
6th grader.
yeah. My 6th grader was done in like 10 minutes. And I was like, no, you got to do Khan Academy or something.
I know. It's so true. What else can I give them? Keep
Exactly.
them busy.
Hey, Ken,
Yep.
could I try sharing? I want to make sure
Sure.
I can run this video.
Yeah, here, I'll make you right now co-host, and you can try out whatever you want.
All right, so I got to share screen. All right.
Yeah, you have the ability now, so you just have to click on share.
All right. So,
Oh, now
let
you
me
can do it.
see something.
Universal's outputting 0 degrees, 90, 180.
All right. So let's see. I want to share. Uh-oh, where'd my share thing go?
Well, so sometimes the control bar disappears on Zoom, but it's on the bottom usually of your whatever video you're looking at.
Oh, wait. I have another window on top of everything. I don't know how this happened. Hold on. Okay, there we
Yeah,
go.
for those that can't see Chip's setup, he has several 4K monitors vertically. It looks like a stock exchange for engineers. That works. Yeah, it's a little bit crazy what you're doing there. You can't see it because of the resolution.
Now, Ken, I want to share a window, right? So I've got everything set up to share windows. How do I do this?
Okay, so go back to the share button.
Right.
And then say new share. And you could choose to share a specific window. I'm gonna mute everybody and you can unmute yourselves. Yeah, that works, Chip.
Okay, you can see the video?
Yeah.
Okay. Oh, shoot. I need to leave it open. All right.
Okay, you look like you figured it out.
Outputting 0 degrees, 90.
All right, so let me get off of share. You can unshare me now.
So you need to stop share.
All right. Okay, am I done?
Yep. Good job. Still waiting for the extra credit high school kids to load in. And for the Shop Talker teachers, I've recorded this for you, okay? In case there's anything you want to play back, and I will put it on a Google Drive and then share it to Steve.
Perfect. Yeah, then I can share it out from there.
Back to all of you. Okay.
Perfect. Thank you.
Yeah, you're welcome. The videos ultimately have more use than sometimes a live event. Well, it's 10 o'clock. How about if we get started? Someone second that, Bonnie? You're muted, but I gotcha. I could read lips.
Okay, second that.
All righto. Welcome to Parallax, everybody. My name is Ken Gracie, and I am more or less the flight controller in this Zoom meeting, so I'm only talking just for a minute. Then I'm going to introduce some very useful people at Parallax. So if you're new to us, what do we do? Well, we do a number of things. This is our building in Rockland that you're looking at. And we manufacture and design microcontrollers like this. This is something we've been working on for an awfully long time, actually, and Chip's going to talk about it. 14 years, and it's our second chip. And where do microcontrollers go? They go into all kinds of things. This is one example. This boat, this is the New Zealand America's Cup boat, and it has 30 of our chips in it. And the boat is ultimately controlled by humans, of course, but all kinds of stuff on it is interfaced with microcontrollers. So we put them in everything from educational robots to our customers put them and stuff like that. And for some reason that slide is missing, so we'll go straight to our agenda. So today we're going to talk to first Bonnie. And Bonnie's going to chat a little bit about what you might want to know about an employer, you know, when you go looking for jobs and work. And then we're going to speak with Kenneth. He's our CNC machinist, and he has lots of good ideas and interesting things to share, and runs our Haas machines and does a variety of things in manufacturing. Then we're going to move on to Terrell, and Terrell's running our electronic assembly. And Terrell's going to just show us the kinds of processes we have at Parallax and then how the machines work. And this is a lot of stuff to cram into 1 hour, all right? So I'm going to be keeping things moving along here. And then we'll talk to Chip. Chip is our founder of Parallax, and Chip has designed our chips, and he'll show what he's doing. And really the goal here is just to show different people, different jobs that we do, and to give you more opportunity to see and hear things, because we're real believers that you learn by doing. It's hard to do right now with our current school shutdown, but we can at least share what we're doing with you, and maybe you'll get some ideas for yourself. And then sometimes when you think you really know what you want to do, you find out you really don't know what you want to do. So it could take a whole lifetime. So we just want to share with you guys. And then as far as Zoom is concerned, we're very open with this, and we encourage you just to unmute yourself and jump in and ask questions. This is a two-way communication, and having run a lot of these events for Parallax, you never want to be talking to a wall. So we encourage you just to unmute your microphone, ask something. This is totally informal. We don't have any protocols here, and you can ask whatever you want. And if you don't want to ask, you could use the chat, and then I'll interrupt our presenter and then share your question. Sound good? Give me a thumbs up out there.
Sounds good.
All right.
Oh, there's a thumbs up
So,
icon.
there is an icon for it, yeah.
Excellent.
So Bonnie, I'm going to pass over to you and make you co-host.
Okay. Good morning, everybody. Well, I was very excited to have the opportunity to talk to folks that might be looking for work, because I feel like we need to shift a bit of a paradigm to put job candidates, everyone looking for work, more into the driver's seat. I want you guys to take great a hold of this opportunity, because finding a good employer and sticking with a good employer for a long amount of time is a huge, huge value to you and any company, not only in the way of benefits, but also in job knowledge and growth and loyalty to your company and the company's loyalty to you as an employee. So I've been with Parallax for almost 17 years. I was in the video game industry, and I worked for a company that took very good care of their employees. I had many jobs prior to that I learned otherwise. So I learned that it's really important, especially in HR. I want to work for a company that knows how to take good care of their people. So in meeting Chip and Ken, I certainly found that as I've been here for 17 years. And so I want to inspire everyone to be an active participant in looking for the right employer for you. Okay, so let's jump to resumes. Resumes are key. They're still being used, even though so many companies still have online submission. You still have to go through that process. But anytime you have an opportunity to turn in a resume, I highly encourage you to do that. This is your first opportunity to show that you're paying attention. So when you're reading a job description and you see all of the items that are necessary in terms of skill and experience and education, plug those when they apply into your resume. Use the same or similar verbiage that companies are using in your resume. Make it easy on the hiring people to see that your resume is full of all the things that they're looking for. It connects the dots for them, makes their job a lot easier, and they want you to be that person. So help them find you. Let's see, always do your research on the company. Go to their website, read as much as you can, find inspiration, find where you have similar beliefs and motivations as the company, like a mission or a charitable organization. That's really important. Identify that in your cover letter. This is your opportunity to break out of the norm of an online submission or a resume as your cover letter. You might find that you have similar interests, and that's where you want to point that out. Give them the reason, like, oh, wow, this candidate looks really good. And it's usually much more evident in a cover letter than it is in a resume. And say, I want this position. Don't be afraid to say, I want this customer service agent, or I want this machinist position at this company. Be clear about what you want. Okay, so you've done the right thing with your resume and your cover letter, and now you've got that phone call. On the phone, you have someone calling you saying, oh, hello, we'd like you to come in on Tuesday at 2 o'clock. Can you interview with us? The answer is yes. Whether you're interested in that job or not, say yes. Every interview experience that you can take is going to be great for you in the long run. So say yes, but do not hang up until you ask two really important questions. Who are you going to be meeting with? Get their names and get their job titles. And secondly, ask how long should I plan to be there? Especially if you have other interviews going on. If you're blasting your resume everywhere, be optimistic. Think, okay, I've got my morning for this company and I've got my afternoon available for any other company. So ask how long for that interview so that you're not rushing. And when you get those names of those candidates or those folks that are going to be interviewing you, go on LinkedIn, look up these people. Learn about these people, find out who you're going to meet, what their background is. You may have worked at the same company as them. You may have gone to the same school. Familiarize yourselves with that person so that you can be prepared and comfortable to talk with them finally in a conference room or in their office. Let's see. By all means, ask me any questions as we go.
Well, hey, Bonnie, I have a question. This is Brian Grigsby. I've got several of my students on here, so it's really great to hear you talk about a lot of these different things that are important in a resume and all that. And you mentioned LinkedIn. Now, do you think this is something, and this is kind of what we've been going back and forth with and several teachers about having high school kids have a LinkedIn profile? You know, there's always a big question about, you know, internet safety and things like that. But from your point of view, do you think that that is something that we should really kind of dig into with kids to get them started on a LinkedIn profile?
Well, I'm very cautious. Me personally, I'm very cautious with social media and anyone under the age of 18. I'm not a huge proponent of it because I am cautious in that way. I feel like there is a safe way to do it, certainly, especially in LinkedIn. If you are employed and you are working, you can do it in a way that you're not sharing information that can lead people into your path. And that would be my motivation, at least for my kids and anyone that's, you know, under the age of 18. I would just want to protect them as much as possible, but still have a professional display on LinkedIn showing that they are making a difference in terms of employment and growing their skills. It does show a great deal of motivation.
Yeah. Okay. Thanks, Bonnie. I appreciate it.
Yep, sure. And speaking of the internet, we all have to be careful there, right? I mean, whether it's Facebook or even Pinterest, people can see what you're interested in. So if it's online, expect that any employer can find it, whether they're supposed to or not. Most hiring managers are going to do Google search your name. So keep that in mind always, for employment and just your own general safety. Okay, so in preparing for your interview, you've got this awesome resume, you've got this good cover letter, you've got the names of the people that you're going to be meeting, you know how long you're going to be there. Now, what do? I recommend mock interviews. Has anyone done a mock interview before?
Oh yeah.
Yes. Anyone that has any major lessons that you learned from doing a mock interview with a friend or a family member?
I'd say, especially in a time like this, record yourself so you can see mannerisms or things that you do, and how your posture is and how that shit comes across, especially on a video chat.
Definitely. So many interviews are happening online now. We need to know what we look like and how we deliver a message, especially when we're caught off guard and we're surprised by a question. You need to know how you're going to come across, for sure. So my husband is a fireman, but before that, he was bombing interviews horribly. It was just terrible. He was making great progress, but he kept bombing these interviews. So he got dressed up in his suit. We put him in a chair. We turned on, back then, the video recorder, and we interviewed him. And within 5 minutes, he was sweating like crazy. And he's like, "Stop, turn it off." So we watched the video and he said, "I figured it out. I'm boring these people to death." So his answers were just so boring. They didn't have any interest. He wasn't telling any stories, and it was not, he missed the opportunity to show off his personality. And that was a huge wake-up call for him. And then he started doing well, and now he's fireman. So it is a very worthwhile exercise. You could Google interview questions and you'll find hundreds of them. It's a really good idea to go through some of the basic ones and have a good answer for them, have a story to tell. It's okay to make the interviewer laugh in your interview. It's much more comfortable and enjoyable for everyone if we can all just relax a little bit and enjoy a conversation, but then also get to know each other and figure out if you're a good member of the team. One thing that I like to do is I drove by Parallax before I had my interview. I wanted to make sure I knew how to get there. I wanted to know what my plan was for parking. I just wanted to get a visual. It kind of took my nerves out. I knew where I was headed, and it's a good idea. Also, what are you going to take to your interview? You're going to take your resume. You're going to take that cover letter. Even if it's a second copy, that's okay. You're going to take a list of questions and a thank you note. So in the past, I've used our receptionist as my screener. So the receptionist will let me know, so-and-so is here, and they were here 5 minutes early, and they were really pleasant, or they were very quiet. So take an opportunity. The receptionist is likely the first person you're going to encounter that works at this company. So it's okay to strike up conversation with the receptionist and say, "Hey, how long have you worked here? And why do you like working here? And do you know this HR manager?" Or, just, you can ask any questions that you want, and just try to settle your nerves and just have a nice, delightful conversation. And then, of course, nice meeting you, talk to you later, because they know the process that you're going through because they've been through it before. Any questions yet? Okay, let's talk about this list of questions. So every interview always ends with a hiring manager saying, "Okay, do you have any questions for us?" And this is a huge opportunity for you. So what you'll want to do is figure out what's important to you. What do I really want to know? And what questions do I have that I learned of that maybe I'm curious about from the website? So here are some questions that I thought of, unless you guys have some good questions. Do you guys have any good questions that you've asked that you sparked up a good conversation with you and a hiring manager or an HR manager?
Where do you see the company going in the next 5 years?
Excellent. Always, always look for the future of the company, because if you're going to be there, you want to be a part of it. Definitely. Any others? Okay, so here's a couple that I came up with. Communication comes in all different shapes and forms. So if you prefer one-on-one conversations in communicating with your team, you'd want to know, what if they all use email? What if they use text? What if you want to do anything but have a face-to-face conversation and you find out that this company only communicates face-to-face? You want to know. It's not a deal breaker, but it's information. Also, what is the cell phone policy? So for your interview, I would recommend leaving your cell phone in the car so you don't have to worry about it ringing in the middle of your interview. But what is the cell phone policy? Because you may have a need to keep that cell phone in your back pocket when you're at work. But the company may say, no way, no cell phones, zero. It's a conversation starter. You can talk about it, but it's a good policy to know. How about training? What kind of training does your company offer? Do I need to do the training on my own? What training should I do now so that I'm prepared for the first day of work? What challenges are facing the department that I'm interviewing for? What challenges are we facing, or when is the busy season, or do we have a slow season? These things are important. You may prefer to go on a huge trip every December, and if they say our busy season is in December, that's going to be a bit of a conflict for you. Let's see, what else? Is this department growing? And how often do people remain employed in this department? Or where do people usually go from this position? Is there a leveling that I can look forward to? And what kind of elevated training or experience would I need to get to the next level? Employers love to know that you're thinking about your future, which contributes to you working with them longer. We put a lot of money into training people and keeping them engaged. And the longer you can work with one employer, the better it is for the employer. Let's see. Also, when you're feeling comfortable with the interview panel or just the person, to ask the question of them, how long have you been here? And why do you like working here? It gives them an opportunity to be a human being, not just an HR manager or a hiring manager or machine shop manager. Let them be human for a second, and they can tell you why they continue working there. Let's see, what else? Do you guys have any other questions that come to mind that you are thinking that you might want to ask?
I have a question.
Okay.
Will the interview be harder depending on how high the job is, like a government?
Ask me that one more time.
Will the it be more harder depending on what the job is, like a government job?
Will the interview be more challenging as the job leveling is changing?
Yes.
So if I'm interviewing for a senior engineer, will that be different from a technician position? It's going to be different, that's for sure. I mean, every type of position is going to have a different level of intensity. We'd like to do some testing. So when we were recruiting for technical support, we have some baseline expectations we need them to have, but we also need to face them with some challenges right then and there. So we'll give them a test. And we've done soldering tests, we've done tech support tests, some IT tests, and it's really just something that they can do on a computer, in a conference room, or on paper. It could be handwriting. There's a huge breadth of things that employers will do to test candidates. And of course, if it's in engineering, in my previous employer, we used to get code samples all the time so that we can review a code sample prior to the interview. And usually that's something that we would discuss in the interview as well. Does that answer your question?
Yes.
Okay. Yeah, that would be another great question. When the person calls you to schedule the interview, you can say, are we going to be doing any testing, so that you can wrap your head around that plan. That way you're prepared. And they might even tell you what the test is going to be about, and that's even better. So when you're going into an interview, realize that the employer is restricted from asking you a lot of questions. There's a lot of protected information that they should not be asking you, but you can ask anything, so that you are in the driver's seat here. And don't forget that, because this is going to be your employer. And I really want everyone to feel a part of this process, instead of just the candidate. Like, you're the person they're looking for. So make sure that you're getting the information and asking the questions that you need to find out if this is the right place for you. And then eventually you're going to get an offer. And what are you going to do with that offer? Do you want to accept it as is, or do you want to negotiate? So negotiating an hourly rate or a salary for an annual salary, that's tricky. But if you've had a good interview and you understand the company, you might have a better idea of whether you should try to negotiate a higher pay rate. Some companies will not negotiate at all, and you just have to accept it. But these are the types of things that you can learn on Glassdoor. Going on to the website, Glassdoor.com is a website where people post reviews of working for employers, but you have to take it with a grain of salt, just like Yelp and any other website. I might love that restaurant, but you could totally hate it.
And often when you're young and starting out, you don't have a lot of negotiating power anyway with salary. It's probably best just to take the job you really want and have options.
That's right. And as soon as you're in there, you really show them what you've got. Show them that you're a hard worker, that you can follow instructions. Another question is to find out if, as a entry-level position, will I have an opportunity to make suggestions on how to improve processes? Or do you really just want me to come in here and put my head down and get right to work? That's another good question and thing to figure out with a new employer.
Bonnie, I just want to say this has been $1 million of advice for everybody.
All right, cool.
Yeah. So thank you so much. And I'm sure these teachers can replay parts of this. Yeah. And also the student who asked about bringing digital portfolios, absolutely. You could bring those things. The point is you just don't want your phone going off.
Yes.
All right. Any final questions for Bonnie? And then we'll go to the machine shop.
No, thank you.
All right. Good luck, everybody.
Bonnie, that was great. Thank you.
Yeah. Thanks so much, Bonnie.
Thanks.
Okay.
I have one more question. I'm sorry. It's sort of going along with my notebook question. Is when we bring in digital videos of projects we have accomplished along with our portfolios, if we're not prompted to bring that up, what's the best way to gear the interview to that, to be able to have that opportunity?
I feel like if you have materials sitting in front of you, you can simply open up. You just open it. I mean, even if it's in your computer bag sitting on the floor, if you pick it up and put it on the table, giving that visual cue is one thing. But also saying, I brought some examples of my work that I'd like to share with you. Do we have time for that? It's as simple as that. And any employer is going to be interested to see what kind of work you've created in the past.
Bonnie, I like that suggestion. Also, timeliness with opening that up. You don't want to come bursting into the interview and start blasting everything you've done. There's something about the discretion. So I've seen that where you can see their personalities and that come through too in the way they bring it forth.
Thank you.
Great. Okay, Kenneth Glass. Thanks again, Bonnie.
Yep.
Hello. Hi there. Where's everybody? Can you guys hear me?
Yeah, we can.
Hear you great.
All right. Well, I'm Kenneth Glass. I work back here in the machine shop over at Parallax. We make all the metal parts that you guys see on our website, ping stands, bearing blocks, motor mount wheel kits, anything that you see that goes out that's made out of metal. It probably came from here, along with plastic little brackets that we make on the laser machine. Let's see, what else do we do back here? We've got 2 vertical CNC machines. If you guys give me a second or go turn it on, there's another Kenneth Glass in this meeting, and it's facing the machine. So I have that on mute. You guys will be able to watch that as I'm talking.
I found your double, and I can spotlight that video.
All right.
And when Kenneth returns, we should ask him to show us the project he's been working on, but I think he's going to do that anyway.
All right. You guys still there?
Yes, we are.
All right, so this is our Haas Super Mini Mill running right now. And it's making this bearing block right here.
Okay, hold that up again. Perfect.
So this part right here, it's got 4 operations. It goes in that machine as like a 3x4 chunk of aluminum. And then as you can see in there, it's going to run through about 10 different tools to get to this point without this stuff on without the tap on the top or this cutout here. There we go. To get these sides done, you know, we got to go 4 different sides. So we're going to do the top first, then it gets flipped over. It'll do the perimeter out here. And then after we get it out of there, we put it up like this, and it's going to mill out right here, that little shelf. It'll drill and tap these. And the last operation, it gets flipped over, and we're drill and tap that so it can attach to whatever your project is.
And Kenneth, describe how that part is used. It's used for a...
Yeah, so this is the bearing block for our motor mount and wheel kit. So the bearing goes in there. We have an axle that goes through that. And we also manufacture a wheel and rim tire combo. So it all gets put together with an encoder that we make here as well. And in that kit, you get 2. You get 2, obviously, a left and a right. Yeah, and so they've been used in a lot of different things. We have one robot, Arlo, that it went in. Let's see. I'm looking at the machine right now, seeing what it's doing. Okay, so right now it's milling out this center, the bearing pocket. So is anybody familiar with CNC?
Yes.
Does anybody know what CNC stands for without Googling it right now? Computer numerically controlled machining. So we're going to use like I said, it holds 10 tools. So this is one of them. This is like a 1/2 inch end mill right there. So that does a majority of the grunt work. Takes off a lot of the aluminum, and then we could go as small as, I mean, the smallest we've used here is 1/32 of an inch. This is 3/16 right here. So it could get really small depending on what you're doing. This is an engraving one, so it's got a point to there. That's how we did all the engraving on the face of this, where it says Parallax. The machine does that.
Kenneth, can you tell us, are you running the machine mostly, or do you also do tool paths and contribute to the design of these things?
Yeah, so this block right here, before it was ever a piece of metal, it was a file in SolidWorks. So we 3D modeled this, and then actually you can build the whole kit is pretty much what we did. Is we drew the whole kit in a CAD program, SolidWorks, made sure everything fit correctly, and then on the computer, once everything checked out, we transferred it to our CAM program, computer-aided machining. So I had a part in those 2 steps as well, and I can't share my screen because I'm on a laptop right now. Let me see if I can open it up. I can give you an example.
Hey, Kenneth, I got a question too. You know, in talking with so many different either machinists or companies and industry about what is the best program to use, whether it's SolidWorks or Fusion or whatever, people obviously have taken their own sides, and some people get kind of rabid about their opinions. But in your in your view, what do you think? I mean, would you just suggest go with what works, or is there any particular program that works better than something else?
Yeah, so actually, funny you asked, because a lot of times a company might already have a license for a program, that you're not used to using. So like in the interview process, that might be a question that you want to ask them. What software do you use? So when I started here at Parallax, I had little knowledge of anything as far as the CAD and CAM program, and I pretty much got stuck behind a computer, and I just self-taught myself on it. So they have SolidWorks. A lot of hobbyists will use Fusion 360 because it's a lot cheaper, more economical. I find that SolidWorks is a little bit better, even though it's pricey. But if you were to go into a company, yeah, I would want to definitely check, because
And
there's
what's
a lot
being used by the high school teachers?
We've been using Fusion 360. I know that we're trying to give a little bit of everything. I know that we're looking into certification through SolidWorks as well. So, to me, it's almost like half dozen, 1/6 of another. It seems like that we're finding right now.
Yeah, I would agree. We've used OneCNC, Bob CAD CAM, and a few other low-end programs, and they're all kind of the same.
Fusion has its own CAM program as well, right? I dabbled with it a little bit.
Yeah, you can do out all the tool paths in Fusion, and it works out really nice.
And then SolidWorks has its own CAM program as well, but we use OneCNC for CAM.
Kenneth, you have been working on a really impressive project where your machine skills and your CAM skills and design stuff all came into play. And one thing I should point out about Kenneth before he shows us that project is he's the kind of guy that will take a kid's electric cart and like hop it up with big batteries and make something neat for his kids. So he's always building stuff. And he's currently has a Parallax welder in his home, taught himself how to weld. So it's really cool when you can make your hobby what you do at work too. That's kind of nice. Sometimes it has a reverse effect. But Kenneth, we've been working on a project with you. Can you show it?
Oh, you must be talking about this project, the gripper kit here.
Yeah, so in this case, turn that thing on and then tell us what you did. How did you work with the engineer and what was your role?
Yeah, so we had a really good mechanical engineer come in and help us with the mechanics of this, the design. It uses one servo back here with this brass rod that goes all the way up here and actuates this gripper kit, so it'll actually grip what you want it to grip at whatever size, and then lift as well. That's a pretty impressive feat to get both those motions out of one servo. His name's Vlad. He pretty much designed the whole thing. I just went in there. He sends a SolidWorks file. He had already had it, range of motion and everything already figured out in SolidWorks, and I just made little suggestions like you can see these little channels in here to reduce the weight. We did that. That's all machined. So all these parts are machined. They're really tiny. You probably can't get if anybody has a Bobot, you can get a feel for the size of that.
You also provided like real world field experience, choosing the torsion springs, the bearing surfaces, tolerances, and then really what you did is you made fixtures too.
Yeah, so every part that we make in the machine, we do what's called a cookie cutter machining. So we don't have 5-axis or 4-axis, we have 3-axis. So we have X, Y, and Z. So our make a soft jaw that has like the outline of these parts in them. So it'll start as a chunk of metal. It'll machine the top side where it gets the outline of the part, and it gets flipped over
and put into that outline that's cut out on the soft jaw so that you can hold the part. So that's really the hardest thing whenever you're designing a product, is that you can have a really awesome product, but if you can't machine it, then you're not going to get that product. So Vlad and I worked on getting all this stuff the way it's supposed to be to get it machined really nice. And I think it came out pretty good.
Yeah, the result is excellent. And by the way, Kenneth's Glass's name is on a provisional patent for this design.
Woohoo! I'm excited about that. My first one.
That's a big deal.
Now,
Yeah.
any students got any questions for Kenneth?
Yes, I have one question. How much weight is the gripper able to like pull up?
Oh, what did we figure out, Ken?
2 or 3 ounces, maybe 4.
Yeah. Depending, I mean, if you want to attach some counterweight to the back, what we have for a counterweight right now is just a servo. So you can put some other counterweights back there and lift up even more. I see a couple of questions in the comments. What do we see?
Some of those are left over from Bonnie.
Where did you get your machine training? I got it from Parallax. So when I started here, I was just helping change out parts, and I learned as I watched. So I've been here for 8 years, and over the course of 8 years, I went from nothing. Parallax actually did send me to a couple training courses for SolidWorks and a couple other things, and then I would study at home. I would take the software home and try to make parts for lowriders, just designing other things, and then apply that at work to their products that they need.
Developing talent from within. It's kind of refreshing to hear.
24 hours.
Yeah, and truthfully, as a small company too, that's what you have to do. That's our choice usually.
Good.
Mm-hmm. Okay,
and
well,
Chip is a great example of that when Chip shows what he's doing. Kenneth, that was awesome.
All right.
Thanks so much. Do you think you can round up your colleague? Hopefully Terrell's here.
I'm gonna pass the laptop to him, and then I'll also get the other laptop so we can see his machines go as well.
Okay, cool. So Kenneth is now taking us next door into the electronic assembly area. And this is kind of the heart of our manufacturing for all the electronic boards we make. And this shop is run by Terrell. All of these guys definitely work together. So although Kenneth is a CNC machinist, he can run the pick and place machine that Terrell's going to show us. And then there's another machine. And generally, we try to get everybody cross-trained to do everything so we're not down.
Thanks, Kenneth.
All right.
So now I'm introducing Terrell.
How you guys doing?
Good.
Terrell?
Hey, Terrell, how's it going?
It's good.
Thanks for your time today. All you.
Okay. You got the other camera, Kenneth?
So what I'm going to be showing today is how we make the Cyberbot job. Yesterday I finished putting all the parts on the panel, so I won't be able to show you how that an actual run, but I do have a demo mode, so we can see the machine running. So it's kind of like you have to use a little bit of your imagination to try to figure out how this thing goes, but I'll show you the best thing I can do. All right, so here's the PCB. You see all those gold pads? Those are just bare pads. And what we're going to do is we're going to put components on it, capacitor, resistors, inductors, all that stuff. So first thing we do, all right, where are we at? Synchronize. All right, now stay back here with me, Kenneth. Yeah. Well, we got two cameras facing us. Shouldn't there be one going out? All right. Got the.
No, this one's facing the machine.
You sure?
Yeah, it's right here.
Oh, okay. Yeah.
There's one of them.
Okay.
Ken will put it on.
I see.
Main screen.
Oh, okay. All right. Well, why don't you move it right here real quick? Show them what the parts are. So these are all the components. These are the feeders, which goes into the machine. These are all the little reels. All a bunch of different capacitor, resistors, values, connectors, all this stuff. So this was on the Cyberbot job. I finished yesterday, so.
Hey, maybe one of you guys can grab the display and point it towards all those reels. Or Kenneth, what you could do is switch to the backside camera. So go down to the video link and then choose the rear camera on that computer.
I think we got it.
Okay, cool. Then I'll spot the video. I'll go find it.
Another Kenneth Glass.
There's 2 Kenneth Glass in the middle.
Ah, yeah, this really helps. I've spotted the video. You guys got it perfect.
Ah, there we are.
Yep. Sorry to follow up so slowly.
Oh, wow, what a lag.
It'll be in the video.
What a lag.
So those are all the reels.
So those are the reels. It was on the machine yesterday, but I took it off because I finished building it. So what I'm going to show you today, right now, is the demo for the PS. Let's see, there it is. Okay. So thanks, Kenneth. This is the BS2 panel. There's there's 50, so it's 10 by 5 modules. We're just gonna show the pick and place in action, so I can explain to you what it's doing. And you can see that there's this spot is empty. That's because there's no feeders. This is just demo mode. This is gonna pretend build. So kind of have to use your imagination for that. All right.
So how long will it take to build a panel like that?
This has 50 individual modules. Let me show you.
And here's a quick look at what he's building.
Yeah, pretty much. Here's one module. And then if you look, it's kind of hard to see, but there's 50 of those in this one panel. There's 500 total parts for this whole panel, and the machine can pick and place all those parts in 2.5 minutes. So, yeah. All right.
That's pretty fast.
Pretty fast. Okay, and that's on mute. Okay, I'm gonna run it.
So what you have to imagine now is that Big Head is picking up parts out of reels with the suction device and has a camera that's orienting them and then placing them on the board.
Pick and place.
It's a pick and place, yeah. Surface mount technology assembly. And he can build about 50 of those little modules we showed you in 5 minutes. And Chip, which PCB package are we using for design?
For which chip?
Not for the chips, but for the boards. It's not Altium.
Oh, you know, I don't know, because it's whatever Michael's using. I'm not sure.
A lot quicker than me with the soldering iron.
Yeah. Yeah, so this would be another neat skill, which is just teaching soldering, and then if you want to carry it to the next step, teaching surface mount soldering.
All right.
It's good, Terrell. It's working fine.
All right. So once that's done, this is what it would look once the parts are placed. This is the Cyberbot job, which I ran yesterday. Put that directly. But as you can see, all those parts are now stuck onto that board like glue. So now we move on to our next machine, which is called the selective solder machine. So it solders through-hole components.
So I've got another quick question, I guess, for anybody that's really out there. In terms of just some of the basic skills, you know, I know there's certainly soldering and understanding electrical circuits and things like that. A lot of times I think that with a lot of the things that we have to do as teachers and try to cover content, we have a tendency to overlook some of the basic stuff. So what would you suggest are some of the really important skills that would be a great foundational learning before we even start getting into any of this stuff?
It's pretty good to kind of learn how to actually solder. That kind of gives you a perspective and appreciation of how things were done back in the days, the good old days, and how things has progressed. Soldering, it's not done as much as before. This is the machine that does all the soldering for me now. But all my soldering, before we had this machine, I had to solder everything by hand, do everything by hand, and learned a lot. You know, when you're put in, you know, harsh conditions, you overcome it, you get stronger. But that skill doesn't go away. And there are times when you need that skill that you've acquired from, you know, when things go rough. Yeah. But it comes in handy. And but this does most of all the soldering, and it's way faster than having one person, two people, or five people. And it's more efficient and it's consistent. So soldering, just even basic soldering resistors or a simple board, and just the fact that you build it by hand, it's, you know, it's a big achievement and something you learn.
Comment while Terrell gets this thing going. So that question, generally I would answer that with attention to detail. Both of these people you're talking to are very methodical. These machines are old. They look brand new. They take care of everything meticulously.
Yep. This machine, the selective solder machine, is back July in 2011. So had it quite a while.
So attention to detail whenever you can, just workmanship, using hand tools, and really taking time to get it right.
Very much. When you're in your own garage, if you mess up, whatever, no one's watching you. It's your mistake, whatever. But when you have to build a product that's gonna go out to customers, you have to make sure it's done correctly, because that goes back on not only the company, but it goes back on your quality and workmanship. And it's, you know, you just gotta try harder. All right.
So Terrell, before you hit the start on that, just a quick video I'm going to share of the product he's actually building.
Okay.
Here they are running. So these go onto a particular robot called the Cyberbot. And this is an example where they're all being controlled by a computer. Okay, back at you, Terrell.
Okay. So, let's see. So these are, this next part, we're going to run the select the solder machine, and that solders all the through-hole components. So we have parts that are called SMT, which are like capacitors, resistors, and all that stuff, and they get soldered and placed through the pick and place. But there's a lot of big components like connectors, headers, barrel jacks. You can't, the pick and place machine can't do, and that's when you use a selective solder machine like this to solder all those big bulky components. Why don't you come over here, Kenneth? Yeah, just use this camera. Oh. So, yeah, I should move it over here. I'm actually going to show this thing. All right. Where's my solder bar? So the solder pot has this in there. So this is a bar of tin. It's a bar of metal. And what the solder pot will do, there's solder in here, which is this metal in here, and it's heated up to 626 degrees Fahrenheit until it's a liquid state. And we're going to use that to solder all these components, all these little guys, all these on top. It's going to solder those together. So let me turn on the solder plot. Maybe just look at that.
And for you CNC users, this is just another CNC machine. And that's Mach 2, Mach 3 software.
Solder, that's liquid molten metal that's gonna use the solder over joints. Load the program.
And Terrell, if you can hear me, can you tell how this machine is programmed?
Yeah, it's pretty simple with the M codes. The program, you don't really manually write it by hand. You use the program to help you program it, but then whatever it outputs is you can see from this camera the view that you can see it's pretty much G code, M codes, all that stuff. But the program, it's simplified. You don't actually type in X, Y's. You kind of just move to your location and you set your point, and it knows where you want to solder or flux.
It's like a GUI, right?
Yeah.
Are you taking the board? Are you taking the bare board geometry to create
Nope.
the G code, or are you actually selecting each individual point and just telling it you'd like a solder joint?
Yes.
Okay.
It's very simple. You
Visual
don't need,
programming.
Yeah, you don't need the dimension, the exact coordinates. You're telling it go here, go here. It's because you're soldering. You have such a big solder nozzle that even if you're off a little bit, you're gonna hit it. But sometimes you need to be very accurate.
So as he drags that around with the keyboard, it writes the G code for him, or M code.
There you go. So it's learning by position.
Yep.
Okay.
And then he can replay it and change it. Yeah, it's totally innovative. And this machine replaces hand soldering and wave soldering.
Definitely. All right, I'm gonna hit run, and hopefully you can see what's happening. So there's a camera that's shooting at an angle at the bottom of the machine. So because you can't really look underneath it.
There's a camera.
So the camera's there to kind of show you where you're soldering at, and you can see from the board it's soldering, and there's components on that one side. So what this machine does, it kind of, you're able to dodge certain spots by changing the nozzle width to go into tighter locations. Versus a wave, you have to tape everything up, seal everything up so you don't damage components while you're soldering.
Yeah, when you've got a mix of surface mount and through hole, trying to do the soldering in the wave would be more time consuming than it's worth, especially if you have this option. I can see how this works around those components.
Yeah, there's a lot more prep work to do. But this, like I said, it's selective, so you select where you want to solder, and it's a very small machine versus a big giant wave machine that like really long. So yeah, I would say it'll take about, let's say, 5-8 minutes for me to solder just one board. This machine can do 4 panel. There's 4 in a panel, and it does it in 2.5 minutes. So it's way faster than me, consistent.
Hey, Terrell, what's the rewarding part of your job? What's the difficult part?
Rewarding, I would say, I started just doing the basic stuff, just labeling bags, assemblies, simple things. And, this place has given me the opportunity to actually move up the ladder, and actually take on different roles as, machine operator. I'm learning constantly about how these machines work and all the quirks, and I'm still learning.
More developing from within. Excellent.
Yeah, and you know, like I'm being what is it? I'm given the opportunity to actually give input and designing the boards, um, instead of just, you know, here you go, do it, and we just deal with it. It's like, oh, let's go over this. This is more efficient. This works better for our machines, because you know, engineers, they don't really know how the machines work. I mean, they don't know how it works, but there's quirks and difficulties, and I am the one who has to deal with it. And you know, if we can talk about it and prepare for, you know, different quirks machines have, then it'll be smooth sailing. We can get it in and out, and you know, less
So
freezing.
normally we involve Terrell right at the beginning of a product.
Yeah.
So the engineer is designing something he can actually make.
Yep.
That's a tremendous benefit.
Yep. All right. So let me take this panel out, and I'll show you what it's done. These are clamps to lock in place. But let's see. How do you see that in the cameras? But all those points are soldered, and that gets washed in our washing machine. So it's that haze you see, it's just from the soldering and the flux, and it just gets washed. All right.
Terrell, that was excellent. Any questions for Terrell?
How long does it take for the solder to dry?
Solder's dried, right? There's no, it's once it cools down, within seconds, it dries up. It's only melted to the point, to that point, and when it melt, and when it dries, like within a second, not that long, because it's not hot no more. You gotta think it heats up to almost 600 degrees Fahrenheit. So when it cools down, it's hard.
What about the washing machine? You gotta use special water, right?
DI water?
DI water?
Nothing special.
For washing machine for circuit board?
Oh, yeah, it's circuit board cleaner. You could take a look at it. It pretty much is a giant dishwashing machine. Has pretty much the same fins, racks, but it's bigger. But it uses DI water, which is deionized water, so it doesn't spray minerals onto our boards and can cause shorts and other problems. Got that, Kenneth?
Okay, nobody fall over out of their chair here.
Yeah, Kenneth.
So that was great. Any final questions for Terrell? We'll go talk to Chip.
With every board you get, you always gotta change the program with every machine.
If it's a brand new product, we program it and design, build it from scratch, and then we build again. We just reload that program and do it. But there are certain times you gotta tweak the program. I mean, when you build the first time, you're gonna build it. You're gonna learn what to do, what not to do, and then the second time you'll learn how to make it faster, better, edit it here and there. So there's always that first, second run where you're trying to make it as fast and efficient and the best quality you can, and after that you just load it up, press go. So there's always a learning curve for everything. Yep. Nothing just comes out perfect the first time.
How often are you guys coming up with new products?
Well, lately, I'd say 3 times a year, our next product is something called a sumo bot. 2 robots that will wrestle against each other. I'd say a few times a year. Lately, it's been more tutorials for education. This product we started a year ago, and it's gone quite well. In fact, if there are any teachers here, you're invited to attend a free training. We provide the robot to you. We send it to your house. And the training, next open one is in July and August. I'll give a link to Steve. And this is Python programming.
I saw that on your website.
yeah, it's been very popular.
Would you consider your company geared more towards the enthusiast or education? I see sometime late last year you really made a transition into the STEM and the education, and then finally with COVID you started getting into the online tutorials and educating educators who could teach others. But you know, where do you see your company here, enthusiast or part of the educational process?
Yeah, it's a great question. Years ago when Parallax started, it was all hobby. And you're going to talk to Chip now, and he made the basic stamp and the core of most of what we manufacture. And his orientation is hobby and electronics, for coding, Apple IIs, all those old computers. And we just took that and we turned it into education over the last 20 years, which has been strong, but we still have big pieces in commercial and big in hobby. And where we're going now, well, Chip's going to show us because it's pretty cool. It's more in the commercial and hobby area, but we're going to support education forever. That's a very productive part of our business. Terrell, that was great.
Yeah, thank you, Terrell.
Yeah, and you know, so that was great. Yeah, none of this matters unless we actually have products we could sell, which are productive, and we make good decisions. So yeah, the next thing you're seeing has been a long-term project that we're just finishing that Chip has been working on for 14 years. And he's going to tell us, and Chip is very self-taught. He's kind of humble like these other guys, but he's learned on his own. Education was not part of his experience really, maybe except for his middle school coding class. So Chip, you ready to go?
Yeah.
Okay, I've made you co-host. You have complete control over anything.
All right. Hello,
Chip is
everybody.
talking to us. He's in Red Bluff.
Mm-hmm.
Hey guys.
I'll talk today about the chip that I've been working on, but first I want to go over a little bit of history. Let me see now. I want to share a certain window with you. Okay, you guys see this picture of the Apple guys?
Not yet.
Wait, I got to hit share. I'm not used to this.
Ah, yes. We know those faces.
So when I was, well, since I was young, maybe 10, I was always playing around with electronics. I would take apart calculators and hook them into the stereo. And in retrospect, I was listening to the scan, the keyboard scan, but always interested in these kinds of things. So my dad was a chemical engineer, and he worked at a company called Aerojet. And he worked there for 37 years. But in 1980, he started using an Apple II at work to do some scientific stuff with. And he would bring it home on the weekends. And I was just completely enthralled with this thing. So I learned all about the Apple II, and I made probably 4 or 5 products for the Apple II back then, and eventually got into the Commodore 64. But the Apple II was just an awesome machine. And it was all due to Steve Wozniak. You see the 2 Steves in the picture. So everybody knows Steve Jobs, but not many people are familiar with Wozniak. But he was the guy behind the Apple II. And he made a fantastic machine that was open. You could get into it. You could learn all about it. You could program it. It had awesome technical manuals and programming support. And it was the perfect thing for me at the time. And later, as I moved into other machines like the Commodore 64, it took me a while to realize that Wozniak had done such a high quality job on the Apple II that what I was frustrated with in like the Commodore products was actually kind of a lack of quality in their ROM and hardware. But Wozniak did everything beautifully. I mean, he was a perfectionist. So I learned a lot playing with the Apple II, and then eventually I did some products for that in the Commodore 64, and I had some money, so I went and I bought let me switch the screen share here. I bought this, a Macintosh, right, which everyone is familiar with. And this was back in '84. I said this picture, it was $2,495, which is about what it cost to get an Apple II back in 1980. And in today's dollars, that's like maybe 8,000 to 10,000 or so. It's quite a bit of money. But what a machine. So, but I got this Mac and I started playing around with it. And it was so much fun to play with all these graphics programs and everything. And then I started looking through all the manuals that came with it. And I looked and looked, and I'm thinking, hey, where's the part how you program it? I mean, this is an Apple product, right? And the Apple II you could program. So I looked and looked through these books, and it was just confounding. There was nothing in any of these half dozen manuals that was about programming the Mac. And I thought maybe I'm just not understanding what's going on here. But later I came to understand that they had a developer program that you had to sign on to. And then they would give you the information you need to program and the tools to program the machine, which was a very much more of a Jobs kind of style approach than it was a Wozniak approach. So at that point, I kind of, there wasn't much I could do with the Mac. I wasn't sophisticated enough to be their developer. So I just started getting into other things. And after high school, my friend and I, who I had met in the 7th grade, we started Parallax up, which at the time was not really much of anything. It was a bedroom at his dad's house. And then I had one. Let's see, Ken, how do I stop sharing?
Hit stop share.
Stop share.
It'll be at the bottom.
The red button. Okay. So we just had our bedrooms at our parents' homes, and we had a dedicated phone line at his place. So we would put little 9th page ads in the backs of magazines and sell our stuff. We made sound digitizers for the Apple II. And eventually, when we kind of found our niche, we were making microcontroller development tools for first the microchip pick parts. And that went on for a number of years. And we had the first economical programmer and in-circuit emulator for the PICs. And that was our business basis for maybe 10 years or so. And what I liked about the PIC was that you could program it. A single chip computer, you can do whatever you want with. So there was some of that Wozniak flair in that kind of work. And I liked that a lot. So since that time, everything we've built has been some kind of a thing that allows people to develop ideas on and build products out of and learn a lot from. Kind of like a playground for your brain. And that's what really turns me on. So at heart, I'm kind of a hobbyist, but our products can find their way, of course, into education and also industry. Now, after we did the PIC tools, I really wanted to design our own chips, because having played with chips and computers for a long time, I wanted to know, how can I make something completely that's ideal to me, based on what I think would be great. So I got this book. This book was published in where'd my, oh, here we go, share button. Let me share something else here. Let's see. Why am I not? Oh, screen 2, screen 3. Oh, does I have to move something onto screen 1 to share it as a window?
You should be able to share windows or entire displays, but in your case, the display is going to be hard for us to see.
Yeah, it's too small. Well, if I do this, okay, you're looking at too much right now, right?
We still see you.
Oh, you still see me? Oh, I got to hit the share button. Hold on.
Now we're going there.
Okay. Does everyone, I suppose this is pretty small, right? You see this book in the upper left-hand corner?
Yes.
That was, in fact, you know what I can do? I can just do this temporarily. There we go. So I got a hold of this book, and it taught me everything I needed to know to make chips. And even though this book is now 30 years old, everything in it is still applicable to designing chips today. I mean, there's some details have changed, but the basics are identical. So this book, I was able to go through this thing without understanding, really much about anything that has to do with the internals of chips. And I was able to learn enough to figure out how, about what it would look like to make a chip. Now this book was written when 0.8 micron technology was, or 0.8 micrometer technology was the cutting edge. So today we're down to 5 nanometers. So that would have been 800 nanometers. So basically today's chips can be over 25,000 times as complex as they could have been when this book was written. But this book still applies today. So I just pulled up a picture of it on the net to show everybody. Now let me shrink that back down. Now what that book showed is stuff like this. Can you see my cursor, by the way?
Yes.
Okay, so you see the schematic in the upper left, right? That shows 2 transistors. And CMOS technology, by the way, stands for complementary metal oxide semiconductors. So there are 2 types of transistors. There are P transistors, which has a little ball at the gate, and there are N transistors, which lacks the ball. So the ball kind of indicates inversion. So this is like the most basic CMOS circuit you could have, I think, because it employs both elements. And this is an inverter. So if a 0 goes in, a 1 comes out, and if a 1 goes in, a 0 comes out. And the way this works is, you see ground down here, right? This is, you know, if you ever looked at chip pinout, you see there's a ground pin and a power pin. So the ground pin is the negative supply. Up in this case, the VDD pin is the positive supply. So if X goes low or to ground, what happens is the PMOS transistor, which has the ball on it, begins to conduct. And it connects the output to VDD. And then meanwhile, the N transistor on the bottom shuts off. So it basically connects the output to VDD via the PMOS. Now, if the X input goes high, the PMOS shuts off and the NMOS turns on, and it pulls the pin, or it pulls the output low. So there are also combinational gates, like a NAND gate would have 2 N's in series and 2 P's in parallel, so that if both inputs are 1, then the output would go low. So in all these really fundamental logic circuits, there's always an inversion going on. Anyway, you can see the simplicity of that. Now look, down here is what this actually translates to in layout. So what you have here is the red is a poly. And then where you have this orange over here and this green, these are called diffusions. And they're doped regions which are cut by the poly. And down here is ground, and up here is VDD, just like in the schematic, and you can see the in and the out. So what happens is the transistor is formed when the poly cuts across the diffusion area and forms a switch. And here you can see what this looks like. Now that's a rather simplistic portrayal, but if we go to this one here, this is more how it turns out in layout. So you have vias and metal layers. The red is the poly, the green is the diffusion. These squares are vias that jump vertically to connect your poly down to your metals, or down to the metal down to the poly.
That makes more.
Which cuts the diffusion. So this is more like what it looks like in layout.
Hey, Chip, do you have a scroll wheel? Can you zoom in on that?
Yeah, let me see here.
Yeah, better. One more time if you could. There we go.
Okay, sorry. Yeah, so that's in practice what it looks like in an actual layout. Now I have here. Now if I make this big, everything's going to look small. But this is the program that I use to design things in. So I'm going to go into this inverter here. Now that looks familiar, right? We just talked about this. So this process that we designed the latest chip in is a 180 nanometer process. So you can see here where it says LG equals 180N. That's length of gate is 180.
Oh, there it is. Okay.
Can you see that okay?
Yeah.
Yeah.
Okay, there, I can make it a little bit bigger. And the width of the gate is 420. The width of the gate for the PMOS is a whole 1 micrometer because the PMOS conduction is about, or I should say the NMOS conduction is about 2.5 times stronger than the PMOS conduction. So PMOS transistors always have to be oversized to get equal conduction. So I'm going to go back out of here, and I have here 3 inverters, right? And they're tied in series. So if we get it, what's going to happen? Does anyone have an idea if we turn this on, what it's going to do? You see there's a bit of a conflict here, right?
Off, on, off.
Someone's writing. Is that you, Ken?
No, they're just trying to sketch out what's going to happen, but maybe you could zoom in a little more on that.
Okay, well, it's just this 3 inverters. Okay, so let's imagine we have a 0 here. Okay, remember, a 0 there. A 1 comes out here. A 0 comes out here. And then a 1's going to come out here, which is now going to replace the 0 that was going into here. Right? So if we simulate this, this is what we get. Whoops. So what we have here is an oscillation, right? And the period of this, whoops, if I zoom in, I have to go into the middle here. This turns out to be a period of about, you can see here, 65.3 nanoseconds to 65.5. That's about roughly a 200 picosecond period. So this thing's oscillating at 5 gigahertz, which is about twice what most of our cell phones use to communicate. But this new 5G stuff, which is tens of gigahertz, can't even be realized in this 180 nanometer process. It has to be done in something very small, like 14 nanometer or 7 nanometer or something like that.
If you added more gates, would the oscillation happen in a greater period?
Yes, let's do it real quick. Let's go back into here, and all I'll do is I'll copy this. But remember, we got to use an odd number, right? If we had an even number, it would just settle to a state, and that would be that. Okay, so here, oops.
Nope, got to drag the whole way.
If I go like this, this will, oh boy, this is being cantankerous. All right, I'm just going to reconnect it. So let me get the wire tool here. So I'm going to connect out. Oops. There's some delay on my end too because of the updating. Okay, there we go. So, oh wait, that's not going to work, is it? That's an even number.
Even number.
All right, let's go one more. All right, did it not? Let's see. Okay, yeah, the wire's not in there. Good. Okay, so now we've got 7, right? 1, 2, 3, 4, 5, 6, 7. So if I hit the play button up here and then go to the simulation window.
Ooh, interesting little ring.
Yeah, so look at that. Our period now is roughly, we're going from about 6.56 to 6.5. Not even that. Well, if we were 2 of these things, we would be now 600 picoseconds. So we're about 1/3 the speed. But you can see now it has, flatter ends because it spends more time in the same state. And we could go into this thing and
that's what that is.
I could probe every one of these points for voltage. I could do this one and this one and this one. I'll get all of them here. Now we can see every phase.
Wow.
It's really fun to design at this level because you're dealing with such small time units and such, you have to make your circuits simple if they're going to work. It's amazing how even one extra transistor can clobber something and cause it to become unstable or just not work right. So it's a lot of fun to design high-speed circuits that do things. All right. Now what I'm going to do next is show you, let's see, I'm going to switch the share thing over to our a program. Oh wait, I've got to stop that share and do a new share.
So Chip's about to show how he took this very low level transistor logic and then he made millions of them, and then turned it into something useful for us all.
Oh, you know what? Maybe I should just keep showing the, I'm not seeing my app show up here, so I'll just share this screen again, but I'm gonna do this, right? Can you all see this?
Yep.
Yeah.
Okay,
Yes,
so
so
this,
maybe zoom in on the one you decide to choose or maximize it.
all right. Can you see this 3D chip thing?
No.
No.
We see a hand pointing at looks like 4, maybe 5 different paths.
The Gortzel example.
Oh, no, okay, hold on here. Hold on, let me try to,
As I mentioned, his wall of monitors looks like
oh,
a
yeah,
stock
sorry, here we
trading
go.
floor.
All right.
You can tell by his eyes where he's
Yeah,
looking, how big he's
that's
got.
a 10-foot swath he just swept across that wall.
Okay, there. Can you see this?
We're getting there. It's a long way from Red Bluff.
All right.
Oh, there you go.
Yep.
Wow. Okay.
All right, so let's see if I hit home here. Okay, thought there was a way to home this. So I'm gonna, what I'm doing here is adding more layers, right? But let's go in and look at, whoa, there we go. So here's part of the layout. I'm creeping in here, and I'm gonna take some layers down. There, can you guys see my little cursor?
Yep.
We can see the cursor, yeah.
Okay, so does that look familiar? That little structure there?
Oh, we just changed views.
Like in a memory array or something there?
This is an inverter. I don't know I hope you can see it, but there's a piece of red poly material.
Yep.
And there's some yellow diffusion that's N-type, and then some yellow P-type diffusion. So
I
this
wouldn't
is,
have gotten that.
and I can add that. So what we have here is we have our diffusion, our poly, the contacts to take it up to metal. Then there's metal 1. So you can see this here is the output. This is the input. This is ground. This is power. If we add another layer, there's the VIA1, and then here comes metal 2. So the way the chip is built is with all, it's kind of like a circuit board, but you can put vias anywhere you want. There's no charge for extra vias. In fact, there are who knows how many in this chip. I know that in this chip we have about 32 million transistors, and every transistor probably has 6 vias, or maybe 5 or 6 vias associated with it. As we build up, eventually we come to the top metal layer. And you see the top metal is very thick. This is where we carry power around the chip.
Power bus, ground bus.
So Chip, you basically showed how to go from a schematic to the physical, to the model,
Right.
and then you moved it actually into fabrication.
Right, and then let's see, I have a picture of what it looks like after it's fabricated.
So this is Chip's second time through this. His first chip he finished in 2006. It was called the Propeller 1. And this is the Propeller 2. And you can guess how long he's been working on this.
Okay, so this is what a chip, can you see this picture here?
Mm-hmm.
This is what it looks like after it's fabricated. See, all the sharp edges are gone because the fabrication process isn't perfect, but you can see all the little vias and the metal layers.
I think we still have a delay.
Yeah.
We're back to the color layers.
To the what layers?
To the individual color layers as you were building up, showing the vias, showing the different layers.
Oh, okay, let's see. Oh, how could that be? Because I put this thing, all right. Let me try to do this again. Okay, here. Now, okay, so now you can see this picture.
Okay.
Wow.
Wow.
Okay.
Winner.
All right. So this is what it looks like post-fabrication. Now this isn't our chip. This is just something I found on the web. But anyway, so it's kind of like a circuit board. So if you've ever designed circuit boards, imagine you actually build the active elements on the board. You don't have to just have footprints for parts, but you build everything. Capacitors, resistors, inductors maybe, all different types of transistors, and all your wiring. So it's awfully fun to make chips because you can just do anything you want.
To give us a sense of scale, what kind of thicknesses are we looking at on those traces?
So I don't know. I don't know what kind of process this is, but in our case, I believe that those metal layers, like where my cursor is, probably 0.5 microns, 0.5 micrometers thick.
Oh, okay.
And I know on the top layer of our chip, we have like a 3 micrometer thick top metal, which is very low impedance. And so always when you're working with these things, you have sheet resistances, which you compute everything by. So I know for our metal one, we have that's the bottommost metal layer. We have 78 milliohms per square. So a square from edge to opposite edge of any size is going to be 78 milliohms. But you can imagine when you make a wire, you can have an aspect ratio of 1,000 to 1 very easily, right? As you route this signal around on the chip. So that becomes 78 ohms. And at 78 ohms with the light capacitive loading that exists on the chip, you can still switch that thing at hundreds of megahertz. It's not a problem.
And Chip, can you show us the demo too?
Yeah, the demo. Okay, so I have here a video. Let me go to that. And let me see if I can share it. I don't see this thing showing up. Let me just do this. I'll share a screen too, and I'll maximize it. All right. Can you see the hand and the finger?
Not yet.
Oh, wait, I got to hit the share. Sorry, I'm not used to this. All right, there we go.
Yes.
Okay, so Ken, do you know if I hit play, will it send the audio directly or?
It depends on your personal setup. Go ahead and try it.
Okay, here we go.
Is outputting 0 degrees, 90,
We got audio.
270, and it's receiving on the center pad. And as my finger moves around, you can see the proportionality as it couples differently between the quads. And this is a 1.2 megahertz sine wave, and we're getting 1,000 gapless samples per second.
All right. So that was a little demonstration of some circuitry that we put into the chip, which can do what's called Gortzel quantizing, where it correlates a reference sine and cosine with some input signal and kind of measures the amount of what it's testing for that's in the signal. And we can also, in this case, output our reference signals, which we were doing on those quadrants, so that we could, by moving our finger, we could kind of couple between those outer quadrant rings and the center pad, and then take measurements from that. So it's kind of like a contactless input or something. And there are some things that, there are some chips you can buy now that do gesture controls, which actually will, notice patterns of like finger movements in front of a small plane or something. And so that way you can have user interfaces which are, input-wise are contactless, but they maybe require a little bit of learning how to use, or they could be very simple too.
So Chip, can you show the chip? And then we want to get some student questions here too.
All right, so the chip, I'm taking the camera over. Here it is on our board. I don't know if this is gonna focus all right. I have to get out a little bit. But right here, that's this chip. And it's about 8 8.5 by 8.5 millimeters of silicon, and it's packaged in a 14 by 14 millimeter 100 pin part. And so this is a board that we make that allows you to program it and write code for it and have a lot of fun. But there's a lot of cool stuff in this chip that I worked for years and years on. Like every pin has analog I/O, both input and output. There's all kinds of trigonometric functions or transcendentals that are in hardware that are super fast. So you can do all kinds of neat signal processing with actually simpler algorithms than if you simply had sine and cosine lookup tables and multipliers. I mean, we have a circuit that does all that at once. It really simplifies Fourier transform down to like just a couple instructions. And then we have, because it has all that analog, we can drive like, VGA monitors directly, or even HDTV. Also, we have this little board here is a HDMI board. It can signal HDMI. We have a bunch of other little, but this board here is a platform to demonstrate, what you can do with the chip, and it has very good power supplies on it. In fact, you can't see, but these little.
So chip's bandwidth seems to be decreasing.
Okay. Yeah.
So Chip, let's see if we can get some questions too. We have these high school students, and you're not a typical high school student. Probably just looked forward to it ending, basically. But it took you a long time to do this, and you learned a lot, and you studied on your own.
Barely got out.
Yeah, barely got out.
Well, the thing is, anybody can learn whatever they're interested in. And today with the internet, what I used to have to scour through books to read, you can just find it, by typing a few things. So this is the time to learn. And if there's anything that you want to learn, you can learn it today. And what I've really come to believe over time, it doesn't matter, your intelligence level necessarily. You'll get the intelligence if you have the interest. If you have the interest, everything else will come to you. You'll learn how to do anything you want to do if you have the interest.
Yeah, and if you have the chance to use your hands. So your CTE teachers that are giving you access to the tools you have in school, I'm sure you guys will really appreciate that. And this is going to be the class you remember when you're older. Doing things with your hands, that makes a lifetime impression. Yep. So student questions for Chip. Anything you guys want to ask him?
You called that device a GORTZ?
Oh, Gortzel. It's a proper noun, so Goertzel. What it is, it's like a single slice of a discrete Fourier transform. It's a way to measure, it's very practical for measuring radio waves, or just checking for some correlation between a known frequency of a known phase and something that's unknown. So in our case, we have it in the chip, so we can output 3 or 4 phases of a sine wave and then measure what's coming back on 4 other pins. And I'm sure it has a lot of application, which we haven't even really figured out yet, but we have the guts to do it.
Chip, there's a question. Is it the same type of technology used in modern commercial processors?
No, because here's the thing. To do a cutting edge chip in a cutting edge process, it's been widely stated that your investment has to be about $500 million. And every turn you make at the foundry is going to be $10 million. So we don't have that kind of budget. We have, a couple $100,000 to put into something like this, and not millions at once. So, for these cutting edge processes, you could probably count on one hand how many customers there are on the earth that can use them. There'd be Apple, Samsung, a few others. Intel has very good processes that it develops on its own, but the money required is so stratospheric that you have to be a huge company or have a lot of money to play that game. So we have to move way down the technology curve to do something, to get some kind of process that's affordable for us. But we can do really neat things with that technology. Now, if we had all that money, we could do even better stuff because our chip could be running 10 times as fast as it does. And maybe someday we'll get there.
So Chip, today, you know, you're over 50 and you're designing chips, and this is a skill you developed your whole life. But it should be pointed out that when you started, since this is really abstract for a high school student, I mean, it's still abstract to me, and I've been around it most of my life now, and I don't understand a lot of what you're talking about. But you built on prior experiences, right?
Oh yeah.
I mean, you started with a soldering iron and a Timex Sinclair computer.
Yep. Yeah, the Timex Sinclair wasn't so accessible, but the Apple II was, you could really learn on. So this chip that we just, all these chips that we made, the Prop 1 and the Prop 2 that we just finished, they are kind of in the spirit of the Apple II. They're designed to be completely accessible to people. You could get this thing and you can learn everything about it. There's nothing that's off limits. You don't need special permissions, special user license agreements. You get it, you play with it, it's all yours, it's all documented, it's all accessible, and you can do whatever you can imagine with it.
So Chip does this, and then our job in Parallax is to make this very easy to use. So in time, teachers will be able to program this and start by blinking LEDs. But it has to be complicated before it becomes useful to all of us.
Yeah, I mean, we have high-level languages which make it easy to start doing things without a lot of background knowledge.
And in the end, you'll be including those objects.
Yeah, and that eases the person into understanding and learning more.
Okay, so we've gone a little bit over, but
just a
that's
question.
Okay.
Sorry to interrupt. Just a question maybe for students that I'll ask. What resources would one need to be able to use some of these products at home if they're interested? What would be a good package for like power supplies and things that can make their own little workbench at an economical level?
Ken, you want to answer?
Yeah, so I'd always start with just getting a robot kit, you know, something $200, and then getting a soldering iron and some extra sensors. You know, go to Amazon and buy some of those really cheap Chinese imported sensors. But I like to work mostly with programming and circuit building on breadboards. And go to learn.parallax.com and start using the tutorials. And there are a lot out there now. It's all on the web for us. Chip, can you show us your monitor setup? Do you have a way to do that with your camera?
Yeah, I have, well, let's see here. I have this green box and the piece of wood to hold the camera, but.
Kind of got to walk out your back door to really get the feel here.
Yeah, so here's my keyboard and mouse.
Oh,
so
beautiful.
You know what? This was cheap. These monitors are 4K monitors. They're 54-inch, and I got them at Walmart new for $249 each.
Yep. But the computer and the video driver is something else.
Yeah, so you just need and a modern video card will allow you to plug in 4 monitors or more. So it's really not that expensive to get set up like this, but it's really nice because the more you can see, now let me see if I can pull up some code here. This is the most awesome thing. When you can see lots of code at once, can you see all that?
Yep.
When you can see like 200 to 300 lines of code all at once, it's fantastic because, how do I close all these now?
Chip, the students who are into gaming are like really frothing at this setup.
Oh, yeah.
I'm just reaching for my reading glasses so I can even pay attention to it all.
Yeah, it's having a lot of code available. What it does, you know, if you're working on programming, you have to have some kind of mental spool up in your mind of where your code is and where the different parts are. But when you can see like this much code all at once, it really relaxes your brain because there's less that you have to remember because your brain uses, you know, visual cues to tell you where you are in your code. This is so simple. So it makes it way easier to program. I can see more at once. I mean, back in the old days on the Apple II, I think we had maybe, I want to say 20 lines, maybe less, maybe it was 15. And then on the, in the DOS days, we had, what was it, 25 lines or so? And to be able to have 10 times that much is just really nice. Makes it a lot easier to program.
Thanks a lot, Chip.
Yep.
Okay, I guess we'll wrap it up now, unless there are any final questions, comments.
Impressed with the virtual tour. Thanks for putting this together.
You're very welcome.
Thanks for coming.
Thank you.
Yeah,
Thanks everybody for joining.
that was pretty amazing.
Have a good day.
All right, thank you.
Bye now.